Hello everyone. In this video, we are going to see about the operation of carry skip adder. In digital circuits, speed is everything. As we move from simple adders like ripple carry adder to more advanced ones, the engineers constantly look for ways to make addition very much faster without making the circuit too complex. That's where the roles plays in. So that's where the carry skip adder comes into place. Um, so carry skip adder also we will call them as a carry bypass adder. And then the idea is very much simple and it very much powerful. Instead of letting the carry ripple through every single bit, we skip certain groups of bits whenever possible. By allowing the carry to bypass sections of adders, we reduce the overall delay. And then we achieve better performance compared to ripple carry adder or carry look ahead adder. So now let us see the operation of an and carry skip adder. So now here we have an and C naught as a 0, C naught as a 0, and then we will do a normal addition. A naught, B naught, sum will be produced. S naught, S1, and S2, and S3. At the same time, the propagate terms P naught. P naught means in the catalog adder we have computed P naught is nothing but A naught and XOR B naught. P1 is A1 XOR B1. P2 is A2 XOR B2. P3 is A3 XOR B3. So let me assume the inputs are 1 0 0 1 and then 0 1 1 0. So this has a naught A3 and this has a B naught and B3. So the A naught input is 1, B naught input is 0. And then A1 input is 0 and B1 input is 1. A2 input is 0, B2 input is 1. A3 input is 1 and B3 input is 0. So now you compute the propagate terms. A0 XOR B0. So it will be 1. A1 XOR B1. So 0 XOR 1 it is 1. A2 XOR B2. So 0 XOR 1 1. And then A3 XOR B3 1 XOR 0 it is 1. So this all the propagate terms is go to the AND gate. This is the reduction AND. So 1 and 1 and 1 and 1. So what happens? What's reduction AND? It will reduce into single bit. So P0 and P1 and P2 and P3. So all are ones. All are ones. So 1 and 1. So what's the output? 1. 1 and 1. What's the output? 1. 1 and 1. What's the output? So 1. So these 4 bits are reduced into single bit. So now the single bit 1 will go and act as a selection line. This one will go and act as a selection line. So if one comes, I can skip this block. I no need to wait for the carry to propagate from every stage. I can directly select this carry as a output carry. Directly I can select this carry as a output carry. Suppose if my selection line is 0, then I have to wait for the block to carry to ripple from one stage to other stage, and then we need to get the carry. So what's advantage? So some block will go for a skip block and some block will not go for a skip. So now let us see another example. Let us see another example over here. Now let us see another example. So now we will take the input as a we will take the input as a 10101100. The other input as a 0101 and then 0101. This has a and this has a B. So we will divide into two blocks, 4 bits. So now the lower 4 bits and higher 4 bits. So this all will go to the ripple carry adder, carry skip adder. So what happens over here? Once again, A naught, B naught, then A1, B1, A2, B2. Otherwise, I'll go it as say with single blocks. The lower four blocks. So A naught, B naught. So this is going to be A naught to A7. This is going to be B naught to B7. So straight away I'll put the values over here. So this is the A naught and B naught. A naught value is 0 and B naught value is 1. What's a full ladder it is? So what's a propagate term? Propagate term is nothing but P naught, A naught, XR, B naught. So 0 XR 1 is going to be 1. And then another full ladder A1, B1. What's the A1 value here? 0. B1 value is 0. So both are 0, 0. So once again, P1 is A1 XR B1. So 0, 0 means output is going to be 0, P1. And then full ladder, and then A2, B2. A2 value is 1, B2 value is 1. Both are 1, 1. So here is going to be propagate term is going to be A2 XR B2. It's going to be 0 once again. Likewise, full ladder A3 and B3. A3 value is 1 and B3 value is 0. So 1, 0, the propagate term is going to be 1, 0 means A XR A3 XR B3, 1 XR 0 is going to be 1. So this is a propagate term. At the same time, it will produce a sum also. It will produce the S1, S2, S3. We are bothered about carry only. So sum it will compute normally. That's not an issue at all. Yes, not. Then carry will propagate as usual. The carry will propagate as usual. A normal ripple carry adder. Seen as a 0. So now okay, these are propagate terms, right? 1, 0, 0, 1. This all will go to 1 and reduction and reduction and. So now what happens over here? So 1 and 0 and 0 and 1. If all the inputs are, if all the propagate terms are 1, it's going to be 1. If any one of them is 0, the output is going to be 0. That's a reduction AND. So this will provide some 0 as a output. That's a reduction AND because if you have seen here, what's a reduction AND? Selection line is equal to 1 and 0 and 0 and 1. So 1 and 0, 0. And then 0 and 0, 0. 0 and 1, it is 0. That's output. The 0 will goes to the multiplexer. The 0 will goes to the multiplexer. This will act as a selection line. This will act as a selection line. So if it is 0, it will select this carry out. So it had to wait for all the full address to come propagate and ripple carry will propagate and then provides a carry out. And then if it is 1, if it is 0 means it will select the carry out, and then if the selection is 1, it will select the input carry. It will select the input carry. So now we have finished the lower block. We have finished the lower block. So now what happens over here? So is going to be 0. So to select this carry, right? So what's a carry here? Compute over here. 0, 1. 0, 1 is going to be 1. 0, 0, 0. 1, 1 means 1. And carry is 1. 1, 1 means sum is 1. And carry is 1. So its output of carry is going to be this C out is 1. This 1 is going selected. So the C out is 1 now here. C out is 1. So now we'll compute for the higher bits 1 0 1 0 0 1 0 1. So now once again you process through the full adders 1 0 1 0 0 1 0 1. So now what do you do here? Like you generate propagate terms, right? Likewise you generate propagate terms here P4, P5, P6 and P7. So P4 0 1 XR here 0 XR 1 1 1 XR 0 1 0 XR 1 1 1 XR 0 1. These are propagate terms. So now this will go to the reduction AND. So all the inputs are 1, so the output is going to be 1. So this will goes to the multiplexer as a selection line. This one will go as a selection line. So if it's 1 means what happens over here? It will select the input carry to the output stage. It will select the input carry to the output stage. And if it is 0, it will select the output carry to the output stage. So now what happens over here? Since it is going to select the input carry, it will skip the ripple carry adder operation over here. That will save the time for us. That's the advantage over here. That's the important point. Whereas here, since we have selected the input carry 1 over here to the output stage, we no need to wait for the carry to ripple to the output stage. So directly we can go for the next stage. That's the advantage of carry skip adder. So in the first block, what happens over here? It didn't in the first block, it didn't skip the block, so it has gone through by stage. The second block, it will the entire block has been skipped, and then the input carry has been selected to the output side. So now if you are doing for an 32 bits or 64 bits, so now what we will do, we will skip we will separate the 32 bits by 4 blocks. So now what happens over here? So now I will separate this 32 bits into 4, 4. So I have separated the 32 bits as a 4 blocks. So there is a one carry skip adder 0, carry skip adder 1, carry skip adder 2, carry skip adder 3, carry skip adder 4, carry skip adder 5, carry skip adder 6, and carry skip adder 7. So we have 8 carry skip adders are there. So now if this go for skip procedure, so then here the delay has been saved. Here if it goes for skip position, the delay has been saved. Skip, 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 skip. So we will save a time delay of large amount of time delay over here. Suppose if we have to suppose if my selection line is going to be, if selection line is 0, we'll go for ripple carry adder carry output. If selection line is 1, we will skip the block. Suppose here if selection is 0, then we'll go for ripple carry adder. If selection is 0, we'll go for ripple carry adder. If selection is 0, ripple carry adder, 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 ripple carry adder. So this is the best case. If all the blocks go for skip, that's a best case. Within a small amount of delay, we will get the output. This is the worst case. If all the blocks goes for an ripple carrier stage, then that's a worst case. So now here we can save a lot of time delay units. Okay, even if among the 32 bits, even if the 2 blocks or 3 blocks go for skip stage, there we can save time delay units. That's the advantage over in the carry skip adder. So through the carry skip adder, we have understood what's the operation of an carry skip adder, and then how skip logic allows faster carry propagation, and then we have compared with the ripple carry adder and carry located adder. Where in carry located adder, its a hardware complexity is very much larger, whereas here it's a very less complexity in the hardware part, the area part. The speed wise, moreover, it's same. Thank you for watching.